I'll just swap back and forth.
And we are live with our 55th episode of Absolute AppSec. I'm your only host today. Crap. And I pulled a Ken.
What'd you do?
I didn't mute the actual live stream. So I was listening to myself say we are live. Great. This is going so well this morning, Stefan.
Oh, man.
At Seth Law on Twitter, Ken has decided to abandon us for, pina coladas, the beach, family time, I guess, whatever Loco Moco Sec, whatever he wants to call it. He's abandoned me or us this week. But happily, we have Stefan Edwards that's joined us at Lojikil on Twitter. Stefan's been on the show before. Stefan, say hi.
Hi.
That was amazing. I know we've been promoting this episode as, Lojikil ruins Infosec, right? We're going to start a series of these because Stefan's a pretty opinionated guy. If you haven't caught that on Twitter or you haven't seen him in live or talked to him before, and I think, between the two of us, I think we think everything is just awful and the worst. And I mean, maybe not the worst, but at least, we can do better, I guess, is really what it boils down to.
Yeah, for sure. I mean, my first major talk was on being an Eeyore in Infosec. So
that's right. I remember that one, right?
Yeah, that was a fun talk.
That was a fun talk. Everything is the absolute worst.
Absolutely.
Yeah. So, I mean, we're going to get into software testing or testing here in a minute. I think from an announcement perspective, outside of the fact that Ken's at Locomocosec as well as half of AppSec Twitter and the AppSec community, Ken and I will be at AppSec Tel Aviv or Global AppSec in Tel Aviv at the end of May. We're teaching our how to code review course. We do get into software testing a little bit in there. But that's one of the things that I wanted to talk about is how it differs, like code review and static analysis from what people think of as testing. I think that's really about it. If you have any questions, hit us up on Slack or on Twitter. I'll do my best to monitor or on the YouTube chat channel. Since we're both here, if I get too distracted by all of the opinions coming out of Stefan's mouth, then we'll circle back around at the end of the episode. But anyway, so software testing. Yeah.
I don't think I'm that opinionated. I think I'm very I actually think I'm very pragmatic with my opinions. I'm not dogmatic at all.
I guess that's true, right? It's just it comes across as, hey, guess what? There's a better way to do this. And a lot of people don't want to hear that, right?
No,
they want the one true solution. And this is partly what I wanted to do to kick it off is we talk about testing a lot of times in application security and product security, but testing means so many different things to different people, right? We've got from just a basic perspective is, as consultants, we have people come to us and say, hey, I need a test done on X, right? On this application. And the first thing that we have to do is we have to go in and figure out what exactly it is that they are thinking that they want. Because testing to them could be a vulnerability scan, like a network vulnerability scan, which is not the same thing as the testing that we do. Or they say penetration testing, they want some red team activity. They want somebody to come in and own their domain infrastructure. And again, that's not something that we view as testing. So we do a really kind of piss poor job in the industry of educating people as far as, hey, these are the different activities that we perform. And every consultancy calls them something different, right?
Yeah, I mean, I think it's even more fundamental than that, right? People don't even understand what they mean by testing itself. Forget about what is infosec testing, what is penetration testing, what is red team activities. What are you actually trying to do with a test? What are you trying to do? And I think a lot of the things that I do is at the programming language theory level or space or whatever you want to do. My annoying quirks of trying to go way too deep into languages and things. And I really think people don't understand the fundamental idea of what testing is versus what specification is, right? Doesn't matter if that's dynamic, static, unit tests versus symbolic execution, whatever it is, people don't understand. In fact, a colleague of mine, Jocelyn, and I have been on calls where clients have said, oh, well, if we switch to symbolic execution, do we need to get rid of all of our unit tests? Can we get rid of all of our unit tests? And it's like, they complement each other, they work in different ways, but they fundamentally do different things. And you're fundamentally trying to do different things with them. So it's an interesting case. We see it all the time, even with higher level testing sets.
Yeah. Yeah. And I think part of the problem is the whole, the drivers behind a lot of the testing are completely different, right? I mean, you've got one organization that is hyper concerned about compliance, say with HIPAA or with PCI. And so all they're really looking for is, hey, how do I check this box? Versus those that are looking for, hey, I want to do a real security test and I want to make sure that I have full coverage, which I mean, I'm sure we're going to get into coverage because coverage completion is, I mean, that's a pipe dream, right? So
I don't know. It depends on completeness and soundness and things like this. I'm sure you cover some of this when you get into your static analysis class as well. Like, how do you read code? Yeah, that level of what is completeness, what is soundness is interesting when you get into higher level forms of testing and specification and everything, So
yeah. Well, but I mean, that's exactly what I wanted to dial in on, because most of the time when someone comes to us and says, hey, we want some sort of testing, if it's a development organization, they're used to doing functional testing. They're assuming that every single function that they're exposing to you is going to be tested for every single, security use case, which is a valid assumption, right? Whereas but depending on the experience of, number one, the consultant, number two, the tester, their experience with that code base or that application, that may or may not be something that they get. I just did analysis of a whole bunch of dynamic scanners, right? Everything from Burp's new enterprise to some of the enterprise tools that are out there. And that's the one thing, from a coverage perspective, all the tools were so hit and miss because it was so dependent on, hey, what does their crawler look like? How do they know what the endpoints are, what the URLs are? And I mean, I know this is kind of higher level than some of the lower level testing that we're talking about with functional and, unit tests and things like that. But it's the same problem that exists for consultants and, the application, testing industry, is coverage is just, it's so hard to prove that you've tested everything when you don't know what the base looks like. A black box test, I'm like, hey, yes, I've tested everything that I can possibly see, but that doesn't mean I just didn't ignore 75% of the application because it didn't get exposed to me via the role that was given to me, right? And they turn around and they give that to their compliance team and say, hey, this application has been tested. 6 months later, they get hacked through that different role. And all of a sudden they're like, hey, why didn't you test this? Or, why do we have these vulnerabilities? And I'm like, because your scope, right? Yeah.
I mean, if you think of the application's input as its domain and its output as its codomain, right? You have this entire semantic search space of an application or a system that you have to test. And in reality, the only actual portion that you intended is this little box in the center of what the actual application is. But there are so many techniques out there in order to discover what that box is. And we very often have huge gaps in what we think that box is and what our program actually intends for that box to be. And we don't get to the point of actually visualizing the box. It's like that old cartoon of what was sold to the client versus what was built versus what was actually given to the client at the end. It's they wanted a tire swing, and what was given to them was a flat swing, half tied to the tree and all that sort of stuff. Everything in between is just completely different because we don't specify things. We don't know what we're actually doing.
Yeah.
We have no understanding of this whatsoever.
Well, okay, so that brings us to what you were saying, like your, specification, just the simple fact of specification versus testing, right?
Right.
So what is it that you say to clients when they come in and they're asking for a test? Like how do you differentiate between those two?
I mean, we do have clients that have come in with a full set of properties at Trail of Bits. It's not uncommon for us to have clients who've come in and have a full set of formal verification or formal specification for their application, right? So they'll come in with a set of invariants that say, something does not change the entire, like no matter what you do to this application, this thing does not change the entire time, no matter what you do. So our tests, like we'll go through and attempt to see if there's anything that changes that, other than like literally changing the value because we have deeper access to the program. Like, can we give it some series of inputs or can we give it some series of states such that the application fails and that no longer holds to be true?
Yeah.
So specification doesn't mean that it's correct. It just means that you specified what you think it should be doing. You still need tests to verify the edges.
Yep.
Specification points out, verification points in. And between those, you actually come up with the area of what your application or system is.
Yeah. Okay. I mean, and that makes complete sense, right? The specification, and this is often what we're trying to get at when we talk about scoping, right? For testing an application is, hey, what is the specification? What is it that we're going to be testing? I mean, it's one of the reasons why I like testing APIs and other things where I have some sort of full specification of what that application does and what it's supposed to do. Because most web applications, it's so kind of fuzzy around the edges. Like it's easy to say, hey, someone should be able to authenticate and you shouldn't be able to see somebody else's. Like there's some of these specifications that we take for granted, but at least the API gives us a formal set of specifications that we can work against when we're doing that testing. Everything else is kind of, I feel like it's so hit or miss. And you came up with that chart, but I think we'll get into that kind of the fuzzing that goes along and how what that actually represents. Yeah.
But I mean, fuzzing, especially like with Sputter or anything like that, when you have those sorts of like random mutation fuzzers, you're really looking for the area, like the area of your application randomly, like a random search of it, versus if you have a specification and you're really walking paths, you may have a different area because the application does something different than what you expected, but at least you're walking actual paths within the application itself, not just random generation that fails.
Yep. Yeah. Well, yeah. And I mean, you've got like your parameters that you send in and things like that. I mean, that was one of the problems I was trying to solve with Sputter when I initially came out with it was, okay, what is the specification? Like, who knows what the specification is for a web application? It's typically not the tester that's walking in the door. It's your developers that, put it together. So is there an easy way for us to define a specification that can be then passed out and tested in some manner? Like you can generate the different the different payloads and try and speed that up, right? But the specification itself is the hard thing to define in a web application. That's all.
Well, I mean, applications themselves are just languages applied over some protocol, right?
Yeah.
I mean, that's the thing behind like LangSec and even Sputter itself, right? When you and I were first talking about how you came up with Sputter, your initial understanding was that the actual language of input was like these 6 to 10 characters that broke everything.
Yep.
That's all you care about is injecting those.
Yeah.
Do you want to give an intro on what Sputter is, since I keep mentioning it and you keep mentioning it?
So I think the initial acronym was like security payload unit test testing
Runner?
framework. Runner. There you go. Runner. Yeah.
I thought it was Runner. Yeah.
It was Runner. You're right. Tells you how much I've thought about that portion of it lately.
Oh my gosh.
So, but the the idea behind it was like we had these vulnerable applications that were written and we wanted to make sure that it broke consistently, like as people were training, and then also when they fixed it, that we knew that it was fixed, right? So someone's learning about SQL injection, they need to implement parameterized queries on this specific query to the database, And when they do that, when I enter the single tick mark and sputter, it doesn't crash anymore. There's no reason that I need to go to the lengths of fully exploiting that SQL injection because I know it exists.
Right.
So instead, like, we wrote this runner so that I could test for the failures outside of a full exploitation or a full exploit. And then it became this whole thing of, hey, well, guess what? Like, all of these different vulnerabilities, I don't really care about whether or not you can exploit it completely, because as a developer, I just know that it's broken and it needs to be fixed.
Well, it eventually became a corpus of inputs, right? Because you changed it to repository at some point, and you actually keep a corpus of things around. I mean, it's similar to like, we don't have to go too in depth with this, but it's similar to keeping like a vector space of all of the inputs that cause crashes and then running those along. It's like Daniel Messier's security list, like fuzz list, fuzzDB, all those sort of things, but more formalized, right? You're lifting it up to a higher representation.
Yeah. Yep. And that was, I generate the payloads so that they make sense for whatever input is going on. But there is the whole, like, hey, you have to build kind of this formal specification on how Sputter interacts with the application itself. And then it'll, if it fails, then it gives you back, all right, it looks like, this character is still having problems. But it encompasses like kind of a full space. And I tried to take those different fuzz lists to that higher level, just like you're saying, so that I didn't have to test as much. I really wanted to speed up the whole process and be able to implement something in a CI/CD pipeline that wasn't, hey, I have to throw 500,000 payloads against the application to know whether it's vulnerable to XSS. I want to throw 3.
Right.
And if I can throw those 3 and prove the same thing, then what's the point of running all 500,000 of those or whatever, instead of just running the couple that I know about?
But you're really shrinking the search space of the things that you care about, right? Like that's really all you want to do with Sputter, right?
Yeah.
Right. And I think just by noticing that there's a search space hack there, you came up with a way of like specifying what you think the problem is. And I guess that's my takeaway from a lot of these, is that people don't actually know what they're testing. Right? Because what's the normal process that we go through? We grab like fuzzDB, run the like 200,000 XSS payloads that it has in there. When in reality, it's like there could be like 10 that you care about. Yeah. Just break, right?
Yeah. Well,
you don't need
that's
to
just
do the whole search space.
I mean, I have a slide on my Sputter talk that's basically what it is. It's like, hey, look at these 50 payloads out of fuzzDB. Guess what? There's a single character that we care about in all 50 of those.
Right.
Because that's what's, okay, we're thinking about cross-site scripting. You're escaping from the, data space into the command space. And there's a character or a sequence of characters that accomplishes that task. The rest of it is just, how do I get something to fire to actually run JavaScript? And yeah.
Did you do search space reduction in order to do that? Like, how did you come up with that minimization there? Or did you like manually brute force that?
I manually brute force that shit. I always wanted to go back. I'm like, oh yeah, I need to write something that'll just go like dump this out for me, because I think it would be interesting to see what it is that I missed from a manual perspective when I went through all those lists.
Right.
But
well, test case reduction is always a problem, right? Even for tools like symbolic execution, abstract interpreters, fuzzers, those sorts of things. Like, they're generating the shrinks or figuring out what the shrinks are always going to be an interesting problem, and it's super interesting to do it over a language of inputs like that.
Yeah.
So
yeah. So it's one of those things on my list. We should get together and talk for a half an hour outside of the podcast.
Yes.
Because I don't think it would be that difficult to actually do. At the time, it was more, oh crap, I don't need one more thing to write, so I'm just going to do this manually. And so it's like any open source project. Oh, there's improvements that need to be made, right?
And we shouldn't be drinking.
We shouldn't be drinking.
Yes.
Not at all. What are you saying?
Because you and I usually end up drinking and then we get nothing done. But
that's true.
No, but I really do think that people don't understand that it's really just a math problem. There's nothing all that interesting to what we do.
Yeah.
Right?
Wait, no. We're saving the world. Come on. What are you saying?
No,
right?
there's nothing. I mean, there's literally nothing interesting about what we do. It's just an application of like some maths. You know, I guess that's my controversial opinion for the podcast today, right? Is that nothing we do is interesting?
That's that. Yeah. I mean, okay. So I've always got that statement, and actually, Ken's boss at GitHub came back and said that, basically the same exact thing, right? That, all penetration testers are like AppSec people, or just glorified QA testers that do it poorly, right? I know I say that quite often because I run into it all the time. And when we get into your kind of graphs, we can talk about why that is. I can't even remember what one of them.
I literally
you brought graphs because it's a math problem. You're right. And that's the other thing is people think that, you're like this, I mean, I don't know how you describe to people what you do, but anybody that's not in the space, it becomes really hard. They're like, oh, well, what do you do for work? And I'm like, oh, well, I do software security. And they just like eyes glaze over. And it basically evolves down to, oh, well, basically I'm like a hacker for hire, right? That's always what it comes, because that's the only thing that they understand.
Right.
And then they're always like, hey, well, can you teach me? And I'm like, you really don't want to sit next to me and watch what I do on a daily basis, because it is super boring, right?
Yeah.
Like there is a little bit where you get that adrenaline spike, you get that, you solve that cool problem and it happens, but a lot of it is just ramming your head against, the side of the wall over and over and over and over again, or automating that ramming until something actually happens.
Right. Right. I mean, I think prior to coming to Trail of Bits, I used to think about us as just glorified QA testers. But then working at Trail of Bits, I've come to realize that the vast majority of QA, and indeed Infosec, is just like janitorial program analysis.
Janitorial program analysis.
Yeah, I mean, so program analysis is like when you're in computer science or theoretical computer science, and you're like analyzing algorithms, analyzing applications, looking at their search space, and that sort of stuff. And I've come to realize that all we do is what's that Greenspun's 10th rule? It's like every large C program is just a half-baked, poorly implemented, underspecified version of Common Lisp. Like, it's the exact same thing here. Everything that we do in Infosec is just a poorly specified, bug-ridden, like shoddy implementation of program analysis. Like, I don't think I'm controversial at all.
No, I completely agree. Right? Like, I mean, we've all read the reports that come out of a lot of consulting firms, and it's like, holy crap, what did you do? Right?
Right.
And even like my initial forays into application security and being an application security consultant, the initial process that I went through on most of those was, okay, here's a QA style tool, right? I mean, we're talking back, 12 years ago, like we're talking AppScan and Web Inspect. Here's a QA style tool. See if you can get it running against this application.
Mm-hmm.
Take 3 or 4 days to do that. If you don't, just take whatever results you have and then do a little bit of analysis really quickly and kick out a report, right?
Well, I mean, how many times have we just like run ACK against an application and been like, yeah, it's all right. Yeah. I mean, like, honestly, it's an area where you just have to at some points. Like, if I'm auditing a code base that's like multiple millions of lines of code, there are very few higher level tools that will run on 4 million lines of code.
Oh yeah.
Doesn't matter the language. Like, I've had clients come to me and say that they have a model for something, some input or whatever. And that's really the way you have to do it, is piecemeal. You have to come up with some portion of your application that you can test at a higher level and then not worry about the rest of it. Yeah. Because you can't. You're not going to get the entire space down to what is the ideal.
Oh yeah. Well, and I mean that's where it comes down to coverage, right? Those extremely complex applications, you have to scope it down, or you have to cut it up into chunks to be able to analyze it. And And then, okay, so you have some sort of functional test or security test that you run against that small scope, but it doesn't take into account, all right, all this stuff that you're ignoring that could have huge security implications.
Right.
And like this even goes so far as, we concentrate on the application security portion of things, but I rarely get into some of that like network operating system layer, like the red teaming stuff. And those guys like eat that up all day long because, people make configuration mistakes. And it's the same sort of idea though, right? If we're looking at one component or one library, that may be super secure, but it ignores the fact that there's not proper randomization going on for, creating, encryption out secrets or whatever. And that's where the security issue exists. So it's going to be very hard to get complete coverage when you're looking at an application of that size.
Well, I mean, it's interesting, right? Like, so there was an intern at Trail of Bits who worked on concolic execution of cryptography problems.
Okay.
So symbolic execution is where you have a symbol that you trace through an application and you apply constraints. So if you have like, if I is less than J, I is less than J is symbolic, and you walk both paths of the if, right? Mm-hmm. So it's very difficult in cryptography or math in general to have symbolic execution of maths, right? There's a whole set of problems that you run into there. And this intern worked on creating concolic, which is concretized inputs from symbolic constraints, right? And,
okay.
And there's a whole science behind doing those sorts of things. But the intern worked on this, and he worked on some real world problems in cryptography's libraries to prove out that they had mistakes or not. And there's a blog post on it. I can link it in here. But it's interesting. We can do these sorts of things. We can do that like higher level testing. It's just we have to apply brains and time. And just as an industry, we don't like doing either one of those. Clients don't want to pay us for it. And then since they're not paying for it, we generally shy away from it unless you work in certain areas or certain research types,
Yeah. I mean, that's another problem that we could, I'm sure we could harp on quite a bit, right? Like the amount of time that it takes to do most of this is not something that clients want to do. And I think that has led to the problem that we have with most of these tools is, okay, we want to do testing, but we want it to fit into our CI/CD pipeline. So I want you to give me full coverage of testing on this application, and I only want it to take, it has to take less than 20 minutes, and it's 2 million lines of code. And at that point, I'm like, I don't know what to tell you, but you're not going to accomplish that, right?
Right.
You're just not, right? Like you're not giving us the time. You're not giving. You have a poor understanding of what it is that you're trying to accomplish, I guess is what I'm trying to say.
Well, I think even worse than that, I don't think clients actually know very not always, but I don't think very often clients know what it is that they wanted their application to do to begin with. So it's like a cascading set of failures, right? Like they don't know what they intended. And then they give it, like business gives that to developers. Developers don't exactly know what was intended. So they write a bunch of stuff that may or may not be like the shape, and you just have this cascading set of like, no one knows what anyone is doing. No one exists on purpose and everyone dies. So let's like get this out the door. No, I mean, seriously though, right? Like,
Yeah.
It's all just a mistake. It's all a horrible mistake. And we don't do anything to make it less of a mistake.
Well, I mean, okay, so I'm going to be honest. As a consultant, when I walk into situations like that, right, and it happens more than exactly what you're saying. Like it happens all the time. As a consultant, I can't come in and say, you should throw this all away because it's complete crap, right? Like that's
I've been on assessments with you where you've done that.
Okay. So I kind of say it behind the scenes, right? Like, wow, look at this finding. Look at this finding. Wow, you shouldn't have done this. And, but like, so that's the underlying, but realistically, that's not what they want to hear. So it's like, you're walking this fine line of you're paying for me to actually do work, but like, I can't tell you that you've got to throw out the baby with the bathwater or whatever you want to call it, right? Otherwise, you're not going to have me come back next year. You're just going to find somebody else that says, hey, this looks great, and then you're going to move on.
Yeah, I mean, it's always a balance, right? Like clients hire you to actually do to do the test, but like, how far do you want to take that with clients when they have completely messed something up? Do you want to do what gets you back in the door next year, or do you want to do what's best for them? And what's best for them may be like, this entire thing is horrible, and you need to throw this out and start over again.
Yeah, those are the situations where I feel bad, right? Like I'm just like, hey.
I have no shame. No, I mean,
of course you don't.
One of the things we have to do is really pull clients aside and be like, look, unfortunately, I don't think you understood what you intended to do. You certainly didn't write what you intended to write. And on top of that, like, we can't test this.
Yeah. Well, and that's just it. Is like, we have those applications, right, that you've tested where it's just like everywhere you turn is a security vulnerability, right? Oh, sure. It's like, oh, look, you've got, you're dumping all of your client data on a page. Oh, look, there's SQL injection across the application. And then they're like, well, what's the worst one? Where should I start? When they, you start reporting the vulnerabilities. And I'm like, realistically, you should turn it off. Yeah. And you should start from scratch, right? You've just got to nuke half of this and go back to ground zero because it's not implemented correctly. And you're always going to be playing catch up. And you're right. You're absolutely right that's going to be that's the correct thing to do for that client, right? Most of the time that also means that they're probably not going to ask you back next year. Mm-hmm. Because you just created a whole bunch of work for them. And in order for them to make their PCI compliance, they've got 6 months worth of work in front of them, and they're going to blame you for it all day long. But I mean, that's being a consultant, I guess. You're right. That's being a consultant.
But I mean, it's like, if you think of one application component or one system as domain and codomain, right? And then as you go back in tensor space or Hilbert space or whatever you want to say, like, as you go to higher levels of dimensionality with other components and fitting together and doing like matrix multiplication across all of those to see the cascading failures and death across the entire application set. I mean, it gets very big. The entire search space that we as testers have to find is bad. The entire search space that they have to fix is bad. I mean, it's awful. I mean, it's really bad, or it can be anyway. It's unique because I was hopeless until I came to Trail of Bits, and now I'm like, whoa, there's actually a potential here to fix things. I'm not always a nihilist. I'm just mostly a nihilist.
Mostly a nihilist. You've been playing in MySpace for too long, where it's just like nothing ever gets better, and
everything is gray. No, but I mean, if you think about it, though, like, really, we have to define, like, as penetration testers, we have to find those edges ourselves in scoping, and then you get in, and there's like, oh, there's actually this entire triangle or trapezoid over here that we completely forgot to tell you about.
Yeah.
And it's just like, nothing you do ever gets better.
Mm-mm. Well, no, it doesn't. Well, it always feels like you come back the next year, right? Like, even those applications that have been tested previously and you've looked at previously, like a little bit of a new perspective. And I think that's what you're saying, a little bit of a new perspective. All of a sudden, you've got more in scope. You've got more that didn't get tested last time. And guess what? It has the same problems as the stuff you found last year. Even though they fixed it in one spot, it still exists in the other, especially with that, the domain codomain that you're talking about. It just like it continually expands, and they like none of these applications are something that is frozen in time either. You've always got new development, you've got new support features, you've got upgraded libraries, you've got all this stuff that's happening. So it's not in a vacuum. The code's not in a vacuum. The testing methods that you're using don't exist in a vacuum. The industry as a whole has moved, and so it just becomes this like. It's a never-ending problem is basically, I mean, I think that's what you're saying, but that's also what I take away from it, and then, we talk about burnout on those things too, because it's just like, all right, well, so what did I accomplish today? Right. Is nothing. Great. I found more stuff. Right. And it's probably not going to get fixed. So, did what I do actually matter? It did to somebody, right? Because now they hate me because I gave them a bunch more work to do, but
I got paid.
I got paid. There you go. I can feed myself for another day. That works too.
I mean, so we do a lot of work in blockchain, right? And,
Okay.
You'll have clients come to you with say Ethereum, right? And Ethereum runs on the EVM. And so there are actually formal models for how EVM operates.
Yeah.
And there are a ton of things. It looks like Tim is messaging me as payback for last time when I was messaging him last time.
I'm sure he is.
But Ethereum, EVM, there are formalizations there that you can actually understand what an application is doing, right? There are multiple ways of actually understanding what an application is doing, what you think you're testing, specifying those sorts of things. And I do think you can empower developers to get better, but we're just not doing it for a lot of things, right?
Yeah.
There's there's Java formalizations, but no Java developer who's writing Spring or struts or anything wants to think about that sort of stuff because the tools just aren't there.
Yeah.
The tools aren't there to warn them that hey, by the way, because of how strings work in Java and the semantics of what you're doing, you accidentally just ruined your performance metrics here or whatever,
Yeah. Oh, no. They don't think about it in that perspective. I mean, it's all driven by business, and that's part of the issue that we're running into, right? Is business has this objective that needs to be met, and testing is honestly as long as it's functional and it works, that's all that they necessarily care about.
Well, it was interesting. Maybe I'll ignore everyone. So this is, by the way, if you've never actually been met me in person, or if you've never spoken to me, as a whole, these are the sorts of things I will text you at random.
I should show my text strings.
Yes, Seth has seen this before, where I will literally text him a set of graphs and be like, "Dude, this is what I was just thinking about." But yeah, I mean, so I tend to think of application search space like this, right? So the upper left corner here is the entire semantic domain of whatever you're running on, x86 or the web or JVM or Ethereum or anything like that. And the ideal is this top right form here. This is what we wish we had, right? I can probably zoom in. I don't know how much I can zoom in on that and have it shown, but what can you see, Steph?
That's pretty good right there.
Okay.
Yeah.
So the top right is the ideal of what we would be looking for. It's the exact box of what we want our application to do. But no one specifies that, or few people actually specify what they want. And so we end up in these situations that are very disjoint. Traditional development, we have these series of points that we think we did, but we have no idea of testing if they're actually within the box that we wanted. And then with traditional testing, we have these sorts of we have tests and we think they represent edges, but then maybe these center tests in the middle here, they may not be tests that are useful for anything that actually shows what the application is doing. But they are tests, they exist and they do things. You can come up with these situations where you have these sort of very facile, very, very in-depth tests that get you to 100% coverage, but they're not meaningful whatsoever because you have no specification to test against,
Yeah.
It's I've seen tests before where someone has specified that that a hash is of a specific length, and it's yeah, that's true. It's a good invariant, right? I'd worry if you came up with a SHA-256 that was not of the correct length. That's a good one, but is that a meaningful test to have? What does that prove about your system, right? But this is what we do. This is literally, and it doesn't matter if you're talking about unit testing and integration testing, or if you're talking about pen testing. This is the sort of stuff that we're doing. We have a bunch of tests, but what the hell do they represent? No one knows. They represent literally nothing because there's no specification there. There's no God that you can hold yourself to, and therefore everything is valid and everything is just completely empty.
Yeah, well, I mean, so this was interesting because I did recently I came up against an org that they did more formal testing, right?
Mm-hmm.
But like I came in and I'm like, okay, I'm going to do like a, a pen test or an application assessment against this mobile application. And they're like, well, can you give us a list of all the tests that you're going to be running? And I said, well, if you can give me a specification, then maybe I can, right? But realistically, you don't have that, and you don't know even what your ideal looks like. You've got your unit tests because I can see those, but that doesn't necessarily tell me everything that I need to run against this. Like, you don't give me enough time. I basically came back and said, well, I can develop a specification and give you a list of everything I'm going to be testing, but it's going to cost you another like 2 to 4 weeks worth of work for me to do that. And they just went, oh, well, never mind, just do your thing, right? Because again, they didn't want to pay for it. But this gets really interesting because I don't think we visualize this enough when we are going into a test. We have our fuzz DB list, and I see fuzzing down in the lower left corner of your graphs here. But like that's what we build off of. So we consider complete coverage to be, hey, what did I discover, right? Like the traditional dev little box. And then did I actually run all my tests against all of those little boxes that are all those little points that I found? But at the same time, it ignores the stuff between there. And I think that's what you're pointing at in the traditional testing graph that you've got, where there's the broken lines, because I mean, we're just ignoring pieces of the application because we don't see them, right?
We don't see them, and we don't even know if the application is supposed to be doing that or not.
Yeah, that's true.
I mean, so frequently we come up with these things and we look at an application as like, I mean, even with applications with formal specifications, you can come up with gaps, or you come up with larger area than what you expected. And that's what I show in the bottom right there. But even with applications with formal verification there, you can come up with weird edge cases to stuff. And it's like, is it supposed to do this? I don't know. So it actually expands out the semantic graph or the semantic area of an application. And it's hard. It's a hard problem, and no one, like, I don't think people like to admit that it's a hard problem because like there are companies out there that are doing great work, like runtime verification. They're doing work in the blockchain space and others. Trail of Bits obviously does that. Another company that does some of this is like Consensus Diligence has some work on like MythX and whatnot to do some formal testing. But it's still at the edges of the empire, I guess you want to say. Like when I worked together with you, I should say, like you and I there were a few times where we talked about like, hey, we could like formally verify this, or we could abstractly interpret this, and the client looked at us like we had 17 heads.
Yeah, they did. They had no idea even what we were talking about in most cases.
Right.
No, we came for a pen test. Yeah.
Yeah, I'm not sure if everyone knows what I'm talking about either, but that's often okay.
we just pretend, Stefan. It's fine.
I mean, I'm so used to it at this point, right? But I mean, I do think traditional testing is like a series of broken lines that we don't really understand what we're doing. And we don't really, because the client has no idea what the app is supposed to be doing, it's very difficult in traditional testing to actually like, actually show what we're doing is meaningful in a lot of ways. Like, can a user actually affect the thing that you're showing them? Like, I don't know. You don't know. You don't know if it's supposed to do this or not. Like, why are you pushing back on me? So, it's really hard. It's very difficult to see this, especially with the traditional testing space, right? And then we do have higher forms of testing, but they're not as often used. And if they are used, they're sometimes very often misapplied, right? Yeah. Like fuzzing. Fuzzing is not a panacea for all testing. There are things that fuzzing won't find, even coverage-based fuzzing. That's why there are some symbolic executors that use fuzzing to concretize their data.
Yeah.
So, I mean, but fuzzing, again, itself is just an attempt to randomly find the edge cases. It's like Monte Carlo simulation for input testing.
Monte Carlo simulation. No, you're absolutely right. I don't know. Like, I think about state of an application and then, fuzz cases. And even what I was trying to, or even what, Sputter accomplishes is that, a higher order form of fuzzing, but it's still fuzzing. and finding those edge cases is great, but there's no guarantee that you found them all. I mean, the scatter plot is what it looks like. Your fuzz graph there. Like there's just so much that you're missing that did it really matter that you did the fuzz test?
Well, I mean, I think what you say about state is interesting, because state machine modeling and state machine invariant, like most applications are actually stateful.
Yeah.
The protocol themselves, or the protocol itself, may not be stateful, but the application itself is actually stateful. And clients are not thinking of state as an input, as a language of state graph transitions, right? And you can model that. You can model all of this shit, and it's actually good, and you're done with it. And that's exactly what you did with Sputter, right? Is that you saw that there are a series of things that break the state change diagram that they expected. And then you wrote a tool that did that.
Yep.
I mean, it's what you see in Mozilla's Dharma. It's what you see in AFL, American Fuzzy Lop. Those sorts of like higher order fuzzers or coverage-based fuzzers that's exactly what they try to do. And that's what, like, at the higher end, we have tools like Mask. Let me find it. A symbolic executor.
This is the portion. Yeah, go ahead.
No, there's a bunch of new symbolic executors and new tools out there to do that sort of assessment space there, or to find those sorts of tests by doing things like matching what a symbolic executor is with what a fuzzer does.
Yeah.
So maybe should I like give a 2-second intro to what symbolic execution is? Because I keep saying it.
Yeah, I think that would probably be good for those that aren't familiar with it. That would be,
which would most likely be most folks.
Yeah, I don't think there's a lot of people that actually do symbolic execution. I mean, Trail of Bits is definitely like, but in like even the consulting space on my side, that's not something that I usually approach even at all. So yeah.
Yeah, I mean, it's something we do at Trail of Bits quite frequently, but that's more because we have tooling and we have the space for it. And unfortunately, there's not as much of that space and tooling out there. Let me just stop sharing and then switch.
Okay.
It's going to switch back to my face, my mug for a second, and then I can.
There you go.
I can actually choose one. Hang on. So symbolic execution is this. We have a series of initial states, right? Like X is equal to some symbolic input 1, and Y is equal to some symbolic input 2, right? And then we have this path where we check, is X greater than 80, right? So simple one, right? So then we generate these path constraints. So we have a path constraint here of X is greater than 80. And if X is greater than 80, we do these sorts of calculations and flow down this tree here, right? So if X is greater than 80, we say X is equal to Y times 2, Y is equal to 0. Now we know the path constraint here is X is greater than 80. So we have a check, is X equal to 256? And then we have the two sides here, is X greater than 80 and is X equal to 256? If X is greater than 80, but it's not equal to 256, we return false, right? So we map out the entire, I love how you're like trying to not smile at this bullshit that I'm showing on screen here.
This is super interesting. Okay, yeah, go ahead. Where is Stefan going with this?
Well, no. So when you have symbolic execution, you can map out all the different paths and the path constraints there. Now, where this actually becomes interesting is that you have tools like solvers or like fuzzers that you give those path constraints to, and then you have them generate code that does this. And does that lead to a crash? So here we have a path constraint of X is greater than 80 and X is not equal to 256. We would give that to a program and it might spit out X is 81.
Yep.
Because X is greater than 80, but it's not equal to 256, right? And then it'll trace through this program and know that it returns false here because we did that. And we can have these sorts of path constraints and analyze our applications under these sorts of things. Now, this is where you get to higher level verification, higher level testing, those sorts of things. But if you don't actually know what you're supposed to do, like, is this a meaningful test itself either, right? It's better.
I mean, yeah, it is. It is better. But like, I think just like the abstractness of the example as well is also like very telling, because without like, yeah, when I look at this, right, I'm like, okay, this is great, but what's the point of this, right? Like,
Right.
why are we doing symbolic execution? What are we trying to prove by saying yes, it's true, or yes, it's false? Because if I don't know that, running this sort of a test and having these path constraints, it doesn't matter to me, right?
So most of the, like, there's a new set of tools out there that form off of there's a paper. I'm going to link it to you here in chat, just like the concolic one. So there's a new set of tests that are coming out, and a new set of tools, like the one that I just sent you, which is automatic exploit generation. And most of these sorts of like automatic exploit generation tools work by doing path search. So everyone remember back to A-star search when you were in algorithm class and all that sort of stuff. They do path constraining, and they do tree walking in that regard, and then they do concretizing of inputs in order to cause crashes.
Okay.
So like at Trail of Bits, we have a tool called Manticore. There's a bunch of symbolic executors, but in Manticore, we actually model x86, and then we model certain states within x86, like a page fault or a buffer overflow. We model those, and then we run a program through and generate a set of inputs that gives us a page fault or gives us a buffer overflow.
Okay.
So that's where I know it seems abstract, like who gives a fuck if X is greater than 80 and not equal to 256?
256,
like, who cares? But like you can actually use these to cause errors if you actually know what you're testing. You have to, and it all comes back to specifications, which we don't have for so many things.
Yeah. Yeah. Well, and I mean, that starts to make sense, right? Like that. Okay. Yeah. Then that's a symbolic execution. Because at that point, if you can figure out what the specification is that leads to a buffer overflow, that's going to give you, that's that automatic exploit that you've just discovered is, okay, all right, now, can you actually execute something? Does that lead to actual,
who cares?
Yeah.
Who cares? Honestly, who cares? I mean, and it's interesting that we have these tools, and it's very difficult to use them because there's just nothing mapping into the space very frequently for them. But that AEG paper, there's a bunch of them that have come out recently that do really interesting stuff with the entire space there.
Okay. Yeah. Yeah. I mean, that's a lot to read, right? So that's too much. Come on, Stefan. No,
that's not, dude. You know me. Like, I will send you reams of tech. Like, I send you papers in iMessage. Like,
oh, I know. I pull it up on my phone. I'm like, oh crap! I got to store this as a PDF somewhere. Get back to it. It's good night reading. No. Okay, so that's our short rundown on symbolic execution. Right? Short rundown. Obviously, if you have more questions, hit us up on Twitter. I did have one question that came in. Let's see. Do you guys find red teamers easier to migrate to AppSec role, or do you prefer getting a QA dev moving into AppSec?
I've done all three.
Yeah.
I've done QA, I've done red team, and I've done like this sort of like I wouldn't say I'm a traditional AppSec person at all by any stretch of the imagination, but I do AppSec now. I mean, that's my general thing, right? So
yeah, and I know, like in general, like the more that we've had the podcast, the more that we talk to people about how they got into AppSec. It's I don't think anybody's really got a traditional path that they took into it. I know people that do pretty well, not necessarily doing like deep symbolic execution, but they do well in like application security and testing applications, and they've come from a red team background. Right? They've learned how to piece together that puzzle typically they've got some sort of coding experience, right? They've tried to build some tools. They've actually learned to read code. Like it's very hard to exist in the AppSec space and not at least have some familiarity with code. But yeah, so like I'd probably say traditional role would be more of a coder, like somebody from dev or QA that moves into application security. I think they have an easier time of it, but it's not the only path.
I don't know. I mean, so as someone who spent time in red team and spent time watching folks like Chris, like people who are much better red teamers than me, I do think that I do think there's some level of coding and some level of like living off the land and some level of like, if you can't code as a red teamer, like you're reliant, like you either have support staff who can code very quickly, or you're mostly running canned stuff. And are you really red teaming at that point? You know? Like it's much more adversarial testing than red teaming. Like red teaming is a lot of thinking on your feet, and part of that comes with it is coding. Now, good or bad, that's another question, but you are coding there, right?
Yeah. Yeah. I mean, you're creating some sort of I mean, at the very least, you're doing bash, like PowerShell scripts at the very least, right? Mm-hmm. If you're a true red teamer, if not Python, you may be writing some exploits, right? Like the good ones, I'm sure are, right? You know.
Oh yeah, absolutely. Or they have a team behind them that do it, right? Yeah. Which is fine too. I mean, it's fine to have a tooling team. Where I worked previously several years ago, like red team was not expected to code exploits, but there was a team behind them that was constantly coding exploits and was constantly looking for that sort of stuff, you know? So within our own environment, obviously. So
yeah. Cool. All right.
Did I exhaust you, Seth?
No, you're fine. You haven't. We can keep going. I was just looking that question came in, so I thought I'd ask it.
No, it's a good one. I mean, it's hard too. People very frequently ask me like, how do I get into Infosec? How do I get into AppSec? How do I get into like red teaming? And I mean, it's just, I don't know, volition, like you want to, right? I mean, if you understand systems and everyone builds a mental model. I don't care who you are. Everyone is modeling constantly. That's the way we experience the world, right? So red teaming is just looking at that model and looking for those edge cases and gaps and tests and procedures much faster than other people are in a live environment.
In a live environment. I mean, we're doing the same thing in AppSec, right? Like that. Mm-hmm. It's a constant, okay, what is this model that exists for this application? And where do the developers make mistakes? I mean, that's where having like some sort of coding background and having built some stuff helps out a lot, is because you know where, I mean, for me, I know where I get lazy, right? Mm-hmm. I do, right? I know that, hey, it may be easier for me to write this in this way, like for a SQL statement, than this way. And I didn't want to look up how parameterization works. So I created some crappy white, blacklist. And guess what? All right, so we need to test that because maybe a developer did the same thing, right? I know we've all done it.
Well, so it's, I mean, you know me, like I want to limit the spaces of our freedom at some points because of that sort of stuff, right? Like very, very Camus, like very Sartre style view of things. But like, honestly, if you restrict the space of things that you can do, it becomes mean. Like there's a programming language called DAL, DHALL, which is sub-Turing. It's proven to terminate. You can analyze it with certain things, and it's actually extremely useful and extremely powerful still. And it's an extremely interesting configuration language because it has it's proven to terminate. So you can write things. I'm sorry?
No. I was just going to ask. I think I found it. It's the configuration language.
Yeah, a non-repetitive alternative to YAML.
Yep. Okay. Cool. Yep.
Like there's all sorts of interesting applications to DAO because it restricts the search space of things that developers can do. And the super interesting thing about DAO is they have a security and safety guarantees page within their wiki.
Really? So like, let me take a look at that. I want to look at it really quick. So what is that? What does that safety and guarantees actually say?
Well, so it guarantees effects, code injection. It guarantees like XSS or just general injection there. Same origin policy, like it talks through types and all that sort of stuff. And then it goes through like Turing completeness and handling program failures and those sorts of things. So there are a certain set of design choices in DAL that restrict your freedom, right? That keep you in the smaller box. But in doing so, it gives you a lot of other safety because it can guarantee certain things about what you're doing.
Yeah, this goes back to discussions that we've had. I mean, even as far back as talking to like Manico and things like that on right the tools that we give developers. Like we tend to shoot ourselves in the foot, right, from a security perspective because we give them too many options. I mean, you think about where most exploits come from as far as buffer overflows and C-level programming languages. The fact that safety is not built into that is a huge problem, and that's where a lot of the exploits come from. So if we improve ourselves and actually give them a model that exists, but I do feel like we end up fighting this line of freedom to be creative, right? Academic freedom. I
mean, I think you can be very creative in programming languages and still do safety very well, right?
Yeah.
I mean, think about it. In C, just take C to pick on C because it's super easy. Like Microsoft, I think it was 70% of their bugs were memory safety issues.
Oh yeah.
It had nothing and do developers actually need like pointer math? Like, do they actually need that? Like, no, there's very few programs and problems that actually require pointer math. But we, for some reason, think that that's a necessary thing to give programmers who have time, including myself. I'm not excluding myself in this. Time and time again, I have screwed up pointer math.
Yeah.
Because it's just like you forget something, it's off by 1, and then you sig-sev and you have done something wrong or use after free or whatever. And we have languages like Rust or Zig or ATS or F-star or any of those sorts of things that everyone glazes over as I say them. That we have things that restrict our freedom but make these things better. You can get things for that. I love how you're smiling at this shit because you do this all the time. You listen to me all the time rant about stuff, and then it's just like,
it's not getting any better. That's why, yeah. But no, you're absolutely right.
In my space.
in your space, right? Yeah. Like I don't know, man. I do see improvements, but I think about the applications that I look at, and it's the same Java stuff. It's the same, you know what I mean? It's the developers that are quickly pushing something out for a business use case. And I don't necessarily see the improvement on the testing side, since that's our, from just a base level, proving the application does what it is supposed to do, right? Taking security out of it, just a general, functional, everything's in place for me to know that this application is indeed complete. It just doesn't exist. If I have tests written for 90% of my, my assessments that I do, like code review, that would be amazing. I think I probably run into 10% actually, have a test written that's not just a stub.
Right.
So I really start to question whether or not there's even any discipline in the industry at all, outside of just kicking stuff out. I know you're in a different space because the people that come to Trail of Bits are looking for symbolic execution. Right. They're looking for that higher order testing. And I know that there's groups out there that are doing at least some of that, just somebody asking whether or not I can provide unit, test cases and things like that. Hey, that's an improvement. But that was a large consulting development firm that asked for it. Most of them are using some fly-by-night system, consultancy out of India that,
right.
Is just churning out code as quickly as possible. And yeah, I mean, I guess that's my rant, right? Is it just, I don't see it on my side.
Well, I mean, I do think though that and this is going to be extremely nerdy, but like by Curry-Howard, right? Curry-Howard isomorphism. If you have types, you're at least constraining the search space of your application via that. And the higher the level of types you have, like for example, let's say you had a string comes in, you append it to 2 other strings, now you have XSS, and now you have SQL injection. Well, what if the string class that you had was like unsafe string, and it couldn't be appended to normal strings, right? Even that simple change that all user input is set to unsafe string, you can now do a whole set of things just by making sure that you have unsafe string in your application. That one change, that adding types, restricts the search space of your application significantly.
Yeah. You're absolutely right. And then you have Django, and they just market everything as safe because they want, you know what I mean? Like,
I do.
Yeah.
I think we switched who's the nihilist and who's the like optimist.
I know we have. You've ruined testing for me. I'm gonna go open a bookstore.
Sell coffee. I mean, like it can really get better. Like with types, with testing, with documentation. I think the reason why I like types better and the reason why I like proofs better is that they're harder to miss. Right? If the compiler tells you you can't do this because of a type system, it's very different from like, oh, we have those docs, we run it when it goes to Jenkins. And then you look at those and like, there's no, like, we haven't updated those in like 4 years. They have no connection to reality. Like that route doesn't exist anymore. It's not called that anymore. Like, that's why I'm against types and against testing and documentation in that way. Because it's very easy to get out of sync, especially if you're not rigorous about it. Whereas types, like, the program enforces many of these things for you.
Yeah.
And then when you get to refinement types and you get to those higher level types, then you get to the really sexy stuff.
Yeah, that's true. So what would you recommend? Like, a client comes to you and is like, hey, we are throwing everything out. We're developing a web application. It does X, Y, and Z. What do you recommend that they use?
Well, I mean, if they're doing something like, let's say they're a C# shop, right?
Yeah.
If honestly, the first thing I'd recommend is like, don't do anything outside of what the framework recommends. Like, don't hack around the framework. You're not smarter than the framework developers, I swear. But if they had to do something truly novel with their work, I would recommend putting in some time to learn Alloy, putting in some time to learn Agda, putting in some time to learn F# and F*, and actually modeling very small portions of your application. Model your input validation system. Model your authentication system. Yeah, I mean, of course, the rest of the application can still be vulnerable, but at least you know those central controls are okay. And as long as you don't deviate from those central controls, you're okay.
Yeah.
And then prove that those central controls do what you think they're doing.
Yeah.
And that can be from model extraction or from refinement types and lightweight verification. But yeah, I would recommend that. Same thing in Java. Like, do some things in Scala, which I know you'll hate, or do things in JML and make sure that you extract an implementation from what you specified.
Yeah.
For small portions, they should be like 100 lines of code, security kernels. Not for your entire application, right? Eventually you'll get there. Eventually you'll do your whole application. But if you can specify your authentication piece, that's a huge win.
Oh, it definitely is. Right. So like, I keep going back to kind of like the code review process and like what I do, what we teach people. And that's always it, right? Is, okay, someone throws 4 million lines of code at you. Guess what? There's certain pieces that are critical to the application. And that's where you start.
Right.
And like, yeah, don't try to do it all. Yeah. No. Start with authentication. Start with the authorization piece that everything's running through, because if that is solid, you're going to have less problems with some of the other things. Like, start with the user input, right? Like, how is that marked as it's coming in? Like, I mean, you're talking about type safe languages, and that's awesome if we can get to that point. But at the very least, if we know that user input's coming in, we can handle it differently, or we can enforce that on a different level than we would at something else. So yeah, I mean, I'm just not sure on how to like how to push that out best to these developers, right? I just that's what I struggle with.
It's frameworks and types. It's frameworks and types. It's like I worked at a large hedge fund previously, and when we got on certain Java applications, we knew we were not going to have XSS, we were not going to have CSRF, we were not going to have clickjacking, we were not, because they had a framework that was super small, super audited. It was like every time you started a new Java application, you must start with this. And they had audited that framework, and they had proven that framework to be correct. And it was kind of like, it sucks, but we're not going to, we know we're not going to get XSS unless they really mess something up.
Yep.
And then the finding is not XSS, but the finding is that you didn't use the framework.
Yeah.
So it was good for us because it reduced our search space, but it also was bad for us because we very infrequently had any cool vulnerabilities. It was very much like, they're using that framework, like we're not going to get anything again, you know, like app doesn't do anything. So, but
yeah, but I mean, I dig that. I dig that approach, right? Like it's the whole idea. I mean, it's all like Netflix. Like we had those like Asta and those guys on, and they've talked about their paved road, right? The developers go in and they use the frameworks and the, you know, the paths that security is blessed. And guess what? It just means that, hey, yeah, we know that there's not going to be XSS. I mean, GitHub with their like CSP policy and all that stuff, it just, you know what I mean? It reduces that risk so much, it almost becomes a boring portion of your job as an application security person, because it is all specified properly.
Well, shouldn't it be boring? I don't think security should be like, security should not be exciting. The fact that the fact that security is exciting is not exciting for clients. I can tell you when you call them and you're like, hey, by the way, I have a critical, you accidentally forgot to authenticate people who are requesting all social security numbers. No one is excited by that. Like, that just means you ruined someone's weekend.
Yeah.
No one loves you for that. Okay.
No one, I know. Gosh.
In fact, they
like
hate
I just dumped your entire customer database, and it looks like it's been there for 2 years. What are you going to do now? Right? Like, well, you're going to be, life's going to be hard, right? Yeah.
Yeah.
Hey, you're right. You know,
I don't think security should be exciting. Security should be harm reduction and safety, and those things are not exciting, unfortunately. No. You know?
Yeah. They're really not, right? And again, you know, people that, you know, want to be hackers or whatever, right? They don't want to do my job, right? They don't want to do your job. They see the one like exploit or whatever that, you know, is pretty cool, or you kind of talk about, but they don't actually see the amount of work that goes into it, and the amount of the amount of time that it's taking you to get to the point that you recognize something like that.
There was someone I follow on Twitter. I forget his handle, so I apologize, because someone's going to do a Twitter search and then they're going to be like, "It's this person, and you forgot his name." But yeah, I think it's Kyle Maxwell. He had a tweet that was like, "Breaking is super easy. Come back to me when you can fix it."
Yeah,
I mean, and it is like, as security people, half the stuff we like I was at a client that was near you, and they were like, "Well, how did you break it?" And I was like, I wrote a shell script that ran Redomsa a lot, and that crashed your application. Here's the input that did it."
Yeah.
Nothing I did was that interesting. Like, I'm not cool. I just I used Redomsa, fuzzed the crap out of it, and it broke.
Yeah.
And that's it. Good luck with that, guys.
Yeah, exactly. Well, no, that's it. I mean, you talk about SQL injection vulnerabilities.
Yeah.
And like it's seriously, for me anymore, it's just like I find one and I'm not super excited about it, because I'm like, oh, they're always like, well, how did you find this? And I'm like, I put a tick mark in a parameter, right? And they're like, and then I ran SQL map against it, and it found a whole bunch of stuff, right? Yeah. And they're like, well, like all I did was use your application. Really, that's all it boiled down to. And I'm like, okay, so show me the code. Let's talk about fixing it, because that's where it gets interesting. But that's also the hard piece, right?
Yeah.
And that's the other thing that I get into with like the secure code review is most people don't want to do the hard work in that. Right? Yeah. Like if I find a vulnerability in secure code review, hey, like it's typically crap, now how do I tell them to actually fix this vulnerability? It's usually not just like switching a parameterized query. It's like, oh, this input's coming in here. You need to create this whole library to actually validate this properly, or you have to create a map of what's, and it's not a super easy solution. As consultants, we are we're still guilty of turning in reports that basically say, here's the problem, and then I'm out. Right?
Yeah. Bye.
Have fun with that.
Good
luck over the next six months of fixing it, right?
I've always wanted to get a tattoo and a shirt that said, I broke your application with terrible HTML and a childlike sense of wonder. Because it's just like, that's all we do, right? That's literally all we do. But I mean, it's funny you say that, because one of the people I have one-on-ones with, he actually asked me, like, why don't you like finding vulnerabilities? And it's like, I don't like finding vulnerabilities because it means I have to write a report, and I made someone sad. Like it's like this weird dichotomy. You want to find you want to find a vulnerability, you want to be cool, but then it's like, but now I have to ruin someone's day, and that's not cool. This is bad. You know? And it's hard. It's hard to walk that line and actually do things and provide meaningful value to clients.
Yeah.
Thankfully, we all die.
Yeah, eventually it doesn't matter anyway, and it's all going to disappear. So I'm gonna become the nihilist now, as that's what we've decided, right?
Oh God.
Oh man. So testing is awful. There you go. Is that everything's awful?
Everything's awful.
It's awful. Everything's awful. I'll put a nice graphic here at the end, and then we can just end it, right? Because I mean, honestly, this was supposed to be a short episode, and we've already gone like longer than usually Ken and I do.
That's how you and I always end up whenever we start talking about crap.
I know. And usually when we've got Ken on here too, he just starts Googling stuff and reading what you're talking about. And that ends. Yeah.
That's like that tweet I had the other day. Hong made one of those like oh really books for me.
Yeah.
Hang on, I'll link it to you in chat. But
sweet.
Yeah, no, it's absolutely the best sort of this thing. Where it's like, what the hell is Logical on about? Like a guide.
A guide. It still didn't answer any questions, I don't think. Right?
It's all just absurdist nonsense anyway. But no, I mean, I do think we can get better with testing. We just, will we? That's the question.
Yeah.
No.
Well, but I think it starts, like having the specification, like we're talking about. That's where it has to start, and then having the tools and the frameworks in place on the other side that the developers are using, it becomes less of an issue. I just don't see us getting there anytime soon, right? Like, I mean, it keeps job security for us for a long time, but I still see developers using old versions of like Spring, and like I still see struts out there as from a Java perspective, and I'm just like, okay, really, we haven't learned anything in the last 15 years. That's what it feels like to me. Is yes, it's getting better incrementally, but it's nowhere near fast enough as the new stuff that's coming down the pipe is just as bad. So,
well, I think we're seeing it in spaces that it can be applied. Right? Like Microsoft is writing a ton of stuff in F***, and they're proving out a lot of their code. Or the Ethereum folks are like proving out that their VM does what they think it does.
It does. Yeah.
And I think it's the same approach for your application. You prove out the critical sections of your like Ethereum doesn't think about like the entirety of the Ethereum ecosystem. They think about, how does the VM work? Does the VM do what I think it does? It's the same for your application. Whatever's the critical component of your application, that's what you prove. Yeah. And then you forget about the rest of the application because it's all terrible and misery and awful. And you just
and it's not going to work how you expect it anyway. No, but at least authentication is secure, right?
I mean, but you start there. You start with authentication, and then you prove that every section of your application is authenticated, you know? And then you prove that authentication does what you think it does, and then you keep moving on, You iterate. You iterate on the tests, you iterate on the specification, you iterate. And then the next time when you have to rewrite it, because eventually everything dies, you can hold yourself to the same specification.
Yeah. Yeah, because it's the same. Yeah, because you've got the same requirements. You got this the same specs there. You spent the time up front doing it. Now anything else that fits into that, or, God forbid you switch over to a different application, you have a specification for authentication that can probably be applied to multiple apps or multiple jobs, what have you, and you can take that with you and improve as you go along. So,
yeah, no, I mean, it's great, but
it's great. No, it's awful.
I mean, we probably lost like half the audience or more here for this entire thing, but
it didn't matter. It was fun. So
it was fun. It's always fun talking to you, Seth.
Yeah, it was good. We've been going for like 80 minutes or some crazy thing like that. So whatever. We'll go ahead and call it for today. If people have questions, they could find Stefan on Twitter and
ask him because I ain't fucking doing nothing.
And I am out. No, if you want to talk sputter, we can too, right? Like how that fits into a testing life cycle. I mean, realistically, like, your recommendations as far as like frameworks and things like that, where to start from are good. And that's what people should be thinking about, but they should be thinking about testing in more than one way, right?
Absolutely.
Yeah. I mean, the more ways that you can prove out that your application, number one, does what it's supposed to do, and number two, is verified as secure, the better off you're going to be. So
I think unit tests, integration tests, property tests, like hypothesis or any of those sorts of things. If you can integrate hypothesis on top of your integration and unit tests, I think you've already won a huge battle there.
Yeah. Yeah. So. And you're miles, if not light years beyond what most people are doing in the space.
I know.
Like
it's sad.
It's sad, and everything's awful. So there you have it.
Everyone's going to be depressed after this.
Well, now I have to go find a drink again because I talked to Stefan on the podcast. So, but let's see. I don't think we have any other announcements or anything today. So, thanks for joining us. Again, if you've got questions, hit me up on Twitter at Seth Law, hit Stefan up at Lojikil. And you can find him, either through me or through other people if you want to as well. If you want to join us on Slack or what have you, feel free. Come in. Let's talk about testing some more, because obviously we have opinions about it. I don't think we're opinionated per se, but definitely we have our views on how things should be handled. So. Cool. Well, appreciate everyone for joining us. Stefan, thanks for joining me again. While Ken's off sitting in the sun somewhere. Hope he's turning red.
That's not nice.
That's not nice. I got done with being nice after he tweeted out a couple of those pictures, so I don't care anymore. No.
Oh yeah, he texted me on the plane. He's like, "Guess who's in first class?"
yeah, exactly. Yeah. Cool. All right. Thanks everybody for joining us. Thanks again, Stefan.
Thanks everyone.